Okay, this is the first of a few short video segments that I'm making, and they deal with some subtle issues that arise when you use shell elements for surfaces. Uh, it, it's very common that in my class, two people sit side by side, and they have two geometries which look identical, same dimensions and everything. For example, here you see two surfaces created, irrespective of how they were done, and uh, they have the same dimensions, and people go to the uh, generative structure analysis, and they measured the shell elements that you see here. For example, these green thingies or shell elements. And when students apply restraints, for example, to the end of these two cylinders, one of them looks like so. In other words, it's pointing out of uh, the circle in the back, and the other one is pointing inside. Okay. Now keep in mind that this is a visual issue in a sense that by clamping that end circle, all that means that the points on that circle do not move at all. So it really doesn't matter how the screen, what the screen tells you, they're saying the same thing. In other words, the points on this circle in the back, in both geometries, they don't go at all. They don't move at all. So what difference does it make if this little thingy is pointing inward or outward? In principle, none. Yeah, I agree with you. However, it's very common that people say, well, why do they look different? Why should they look different? Now, the other one is when you apply pressure on the surface, in one case, it looks like so on the left side. It's as if it's trying to compress. The pressure is applied on the outside of that cylinder, or think about it as having a vacuum inside. In the other case, the cylinder is actually pressurized. So the question with the student is why? Why should they do? Of course, the remedy here is very simple. If it's internally pressurized, you can click on this pressure on the left side, on the left geometry, and from a positive value, you make it a negative value. And of course, immediately the arrow reverses, and it indicates to you that it's actually being pressurized on inside. However, it will still be sitting on the outside of that surface. Okay, although you corrected the issue by changing a positive pressure to a negative pressure, however, visually they look different. Okay, the question is why. This is what I want to show you today, and people don't pay attention to it because, generally speaking, we fix these things by changing positive pressure to negative pressure. It's basically doing whatever I want. But the question is very often, why does that happen? So let me go ahead and create these two side by side, exactly like it is. And we're going to go through step, and I show you if it's bothering you that they look different, or if you want to know why they look different, then I'll show you what needs to be done. Okay, so the dimensions here are totally irrelevant, but because I want to make them the same, so I better put some dimensions. Now, first of all, I want to create surfaces. And of course, I can start in a part design, make a cylinder, and extract the outside surface. That's okay. That's one way of doing it. Or you can do this thing in generative structure analysis, generative shape design, and create two circles and path. This is where you want to do some stuff with surfaces. The more elementary version or the stripped down version of this generative shape design is wireframe and surface design, which is right here. You can see that start mechanical design, and down second from the last it says third from the bottom, this is wireframe and surface design. This is a very simple surface that we want to create, so we can do it either in this stripped down version, wireframe and surface design, or in generative shape design. It really doesn't matter. Let me stay here. Okay, so first of all, on the vertical plane, I will sketch a circle of diameter 2. Here's a circle of diameter 2. Let me dimension it first. Okay, now diameter, we change that thing to 2 inches. and I'm going to place it exactly 2 inches away, or maybe 1.5 inches away from this axis, because I want them to be side by side, just like the screen that I showed you a few minutes ago. Okay, good. All right, and then exit, and then extrude it. Here's the extrude right there by the default value, which is 2 inches, which is 0.707 inches. It really doesn't matter. I don't care. Okay, so you can see here that the extrude has been created. I want to do something that is that is critical in trying to convince you why do things happen in this way. And let me look at there's an icon join here. So this is a surface, and I can use it to do the rest of the problem. But I'm going to join it because you will see what the role of this join is. So I'm going to select this extrude and join it right here. Extrude and join. Okay, let me also create another circle on the left of this and do exactly the same thing. So on the vertical plane, once again, I will sketch. Make sure you don't go and do it in the same sketch that you just did a minute ago, because then it becomes two circles which are being extruded. That's not what I want. I want single surface, single circle, which is being extruded. So we already did one of them. The second one is going to be down here. Okay, so let's make it diameter 2. And put a dimension from the center of this to that, 1.5. Okay, exit and extrude it by the default value. Okay, now notice that if I had drawn both of those two circles on the same plane, then there wouldn't be two separate extrudes. There would be a single extrude from the same sketch, which is two circles. That's not what I did. Individual circles extrude individually. And I'm going to join this. Okay, so let's join it. Join this last extrude that I did. Okay, there we are. And we're good. Okay, good. So I joined the first surface and I joined the second surface, and I join them together. I can't join these two together, then it becomes a single surface, and that defeats the purpose of what I'm trying to show you. Now let's apply some material on this thing. Metal, I don't know, aluminum perhaps. It really doesn't matter. There we are. Okay, good. So we have created our geometry. Now we're going to go to generative structure analysis. Because there are no solid elements involved, here, let me see. Let me cancel this thing. Back there. Try again. Generative structure analysis. Static analysis. Okay. Where's my tree? I think the reason I actually, oh, there it is. I didn't have to go in and out. So F3, the tree was missing. Very good. Okay. Now, we're going to mesh these things. So this is a triangular mesh or shell mesh right here, 2D going on surfaces, octi-triangle mesher. I'm going to do the first one right there. Okay. I'll use linear. That's totally irrelevant. The size is irrelevant because I just want to see what's going on with those arrows in this figure. Why do they look different? And do the same thing on this side to mesh this. This is the other one with the same type of element and same size. It's irrelevant. Here are the two meshes that I created in that. Let's put some thickness. So 2D property on that. I don't know, 0.2 inches. Okay. Totally, again, irrelevant. And put a dimension here, thickness on that shell. Okay. Now, so first of all, notice that although I have created the surfaces, my sketches are still on the screen, right there. See these green things? The sketches are there, and I better hide these, because if you inadvertently put the clamp on that sketch instead of these end edges, finite element will not see it, and it pretends that there is no restraint on it. Okay, good. Now, let's carefully do this. Here is a clamp right there, the clamp. And I'm going to select this edge, and you'll see that it will put the those clamp icons some way, right there. See this? Inward. Fine. And do it again on this edge. So clamp again on this. And notice that they look the same. They look the same. Perfect. All right. Now let's put pressure. Let's put a pressure here. Pressure, whatever the value is, totally irrelevant. So there, and notice that it put it on the inside, right there. You see this? On the inside. Excellent. And do it again on this one. And once again, it puts it on the outside. And you might say, well, wait a minute, didn't you say that these are going to be different? Well, you'll see why they can be different. See that? They're not both on the same side. They're not both inside or both outside. That's the whole point of this video segment. I want to show you why. Okay. Now, of course, I can run this. Let's run it. It's not a big deal. It's just going to take. I might get some error, some warning messages because of the size of the element and things like that, but that's really not the point of this video segment. Yeah, okay, so this says that you have a bad mesh. Now, that's fine, I understand. Okay, now look at the deformation. For example, the deformation. They're both internally pressurized. As you can see, both internally pressurized, and obviously they both expand. Yes, I mean, you can see that they interfere with each other because they have no idea. The other one is sitting there. Basically, I did these two models independently of each other. I could have made the separation more so that this would not happen, but that's really not the issue here. Okay, so let me deactivate this plot. So back to the issue. Why is it that here they came out to be different, and even the clamp icon visually looks different, but these are the same? Okay, let's go back to our CATIA model, which is right here. Remember, we made it part to go to the part design. There were the two joints. Let me go back to the first joint. Let's go there. There we are. Okay, good. So I am now out of the FEA module, out of the generative structure analysis, and in the generative shape design. Okay, if I click on this thing, double click on this thing, left double click on this thing, notice that it gives me a red arrow pointing out, which is fine. And let me click on the other one. See, this is fine. This is for the first join. See, for the one on the right side, the arrow points up. When I do it for the other one, it also points up. So let me flip this arrow. For the second one on the left, for the one on the left, I click on it. Notice that it puts the arrow inward, and I say OK. Okay, so this one, the arrow is outward. This one, the arrow is inward, into that cylinder. So if these are the same, in the same direction, this one was outward, this was in, if they were in the same direction, visually, you'll get exactly the same thing on the screen. If they're in opposite direction, and here I made it opposite by double-clicking on this red arrow so that it actually flipped it in the other direction. See, I don't want it like that. I want to go in this direction. Then you will have differences. So here, for example, this is the same thing that I showed you. One goes out, the other one goes in. And by the way, what I did here is that I did these separately and screen capture and put them together. You can't do it at the same time because these are separate surfaces. You cannot see these at the same time simultaneously. Okay, that's fine. Okay, so now we go back to our analysis. Okay, right there. Back to our analysis. Don't worry about that. I know it looks kind of intimidating, but that's okay. And let's run it. Let's now run it. Momentarily take a second look. These arrows now point in the same direction, just like before, But as soon as I run it, the arrows of this will flip, and these little red clamps will actually point in the other direction. So let's run it. This won't happen until you run it. Okay. There, you see that? The arrows are on the outside now, basically creating a vacuum, saying that I have a vacuum inside. And this little blue thing, which was red before, and it was on the inside, just like the one to the right, is now on the outside. That's fine. Don't worry about the box. Bad mesh. Okay, so just think about it for a second. This one says I pressurized inside, just like before. This one, because it's still positive 10 psi, but it's pointing in the other direction, it's as if I've created a vacuum. So if you go ahead and look at the deformation, this guy is being pushed out. The cylinder is pressurized inside. This one, there's a vacuum inside. So you get the picture. In other words, why is it that two people sitting side by side, what they do, they may look different? Now, of course, I don't bring these issues in my course. Basically 6 weeks of finite elements and showing the basic. What I tell them is that, okay, if this is bothering you, no problem. Go to this. Let me go back here. Where is the FEA? Right there. Go to the T. I have two pressures right there. This is the one that I don't want. I wanted to flip the direction. I did it through changing the direction of the arrow in the joint. But here I'm going to say, okay, no problem. Make this thing 10. If you make this thing 10, if you make it minus, you see that? As soon as I said minus, this thing is now pointing out, which means as if it's also pressurized. And you run it, okay? And if you look at the deformation, they do the same thing. So yes, I could have avoided all this direction, changing the direction of the joint, normal to the joint, etc., by changing 10 psi to minus 10 psi. But as I said, often the question that I'm confronted with is, why are they different in the first place? And we found out why, because in join, if you go to join, if you double click on join, this join surface has a normal or direction of a surface outward, whereas the other one has a direction of the surface which is inward. And when you think about it, that kind of should make sense, because when you talk about the surface has two sides. One is a, people usually call it positive side, the other one call it negative side. It has nothing to do with positive or negative as numbers. It has to do with the direction. By convention, when you create the surface, which side you want to be made distinct from the other side. And the direction of the normal, as I've shown you, is the one. So when you're dealing with surfaces, it's important which side are we talking about. Now, the next video is going to show you, if you're not careful about this, it can get you into trouble. I already showed you what happened, because in one case you get the vacuum inside of the cylinder, the other one is pressurized. So the second video is kind of a continuation of this thing, but we'll see. Good luck.